Good day and welcome to the DB CyberTech's webinar on GDPR Continuous Compliance, How to Discover, Classify, and Protect Personal Data. Following the presentation, there will be a demonstration and concluding with time for questions and answers. You may also enter questions at any time throughout the webinar by using the chat feature located in the lower left corner of your screen. Today's webinar is being recorded. At this time, I would like to turn the webinar over to Dave Rosenberg, CTO of DB CyberTech. Please go ahead, Dave.
Good afternoon. I'm Dave Rosenberg, CTO at DB CyberTech, the leader in predictive data loss prevention for databases. We're focused on understanding structured data in a business and security context. As we've watched the GDPR evolve and now come into effect, we've realized that the vast majority of the most critical personal data subject to the regulation is naturally stored in databases. There are great challenges and opportunities for managing this information, and we're here today to share our insights into how to stay compliant with the GDPR's regulations on structured data. Next slide, please. By the end of this webinar, you'll understand the key steps and technical capabilities you will need to remain compliant with the GDPR's regulations on your structured data. Along the way, I'll describe how DB CyberTech solutions are uniquely poised to aid you in this process. Next slide, please. Let's start by putting things into perspective. As you've likely heard, the GDPR requires not only technology, but an array of processes and policies. Companies, their data protection officers, and IT security professionals must answer to end users, auditors, and their employers. For each of these constituents, the GDPR prescribes specific processes and responsibilities. In short, it is no small undertaking to become and stay GDPR compliant. The GDPR is a broad regulation. No single solution can address all its requirements and implications. However, if you control or process any sizable volume of personal data, chances are that the most important elements are in structured form, that is, in databases. You can take advantage of this structure with the right tools and technology to greatly reduce the effort needed to remain GDPR compliant. That's the key message of this webinar. Next slide, please. Here's what I mean. For structured data, there is a simple, well-defined list of priorities. First is assembling a record of processing activities as mandated by Article 30 of the GDPR. Establishing this baseline is essential to staying compliant by largely automating what is in fact a continuous process. To do this, you'll need an accurate and comprehensive inventory, one with granular visibility into your processing activities, one that is easily searched and exported. The best and least costly way to create such an inventory is via continuous monitoring of your structured data environment, leveraging intelligent and autonomous data classification. We'll see what this looks like shortly. Next is an overall approach to security. Rather than consider how to get in touch with supervisory authority when something goes wrong, let's focus on making sure you never have to. The GDPR insists on a process for testing, assessing, and evaluating those specific measures, ensuring your data processing security under Article 32, and painstakingly reporting any breaches under Article 33. The reporting duty is quite specific in the regulation, which gives just 72 hours to report a breach, and critically, only 30 days to address requests by data subjects to locate, correct, remove, or even export their personal data in a neutral form usable by other vendors. How are you going to do this? By far, the best approach is to take advantage of real-time visibility into changes in your processing activities, combined with automatic behavioral modeling to alert you to the potential for a loss of personal data before this happens. If you invest your time and effort proactively, you can minimize the risk of fines and costly remediations inevitable in the aftermath of a data loss. Even better, under the theme of incorporating privacy by design into your data processing, each time you conduct an impact assessment of new or modified activities under Article 35, you'll be able to leverage intelligent data classification and automated baseline comparisons to quickly assess risks and dramatically reduce the ongoing costs of compliance. Finally, let's consider the rights of the data subject. Suffice it to say, these have gotten the lion's share of recent press coverage. Your data minimization effort is where the rubber meets the road. If you scatter personal data throughout your structured data processing infrastructure, you'll have that much more work to do when you correct or remove data for a specific individual. Likewise, if you don't effectively track what kinds of data you have for a subject, you'll have that much more work to do. To identify your best opportunities for data minimization without disrupting normal day-to-day operations, and to measure your success, you need a non-intrusive solution that does real-time data mapping and classification. Next slide, please. Before I proceed, we should acknowledge that structured data privacy implies security. We must not ignore that database breaches that really matter, those leading to data loss, are not slowing down. What do database breaches have to do with the GDPR? In virtually every large public breach in recent memory, ask yourself, what was stolen? What was its nature? The answer, personal data, the very thing now so assiduously regulated by the GDPR. Had this regulation been in effect, each of these recent breaches would have incurred stringent reporting requirements and quite likely substantial fines. Next slide, please. Some companies will try to sidestep the challenge of GDPR compliance by simply cutting off access to their services. That is, foregoing the potential business of more than 500 million EU customers, as identified with the blunt instrument of their IP addresses. This is obviously counterproductive for most companies for which the EU is simply too great a market to ignore. Furthermore, this generally won't work, as effective companies have most likely already collected personal data subject to the GDPR. This ship has already sailed. Indeed, many prominent companies, including Google and Facebook, are already under the GDPR microscope. Ask yourself, will I be next? Next slide, please. The GDPR is not really touching new ground. My focus and our focus at DB CyberTech has been on structured data for many years. It is now common knowledge that data loss simply happens on a regular basis, and what gets reported to the public and what can get you fired is the loss of personal data. In this light, the GDPR's 72-hour reporting requirement is ironic, because the typical time required to discover a data loss is more like 120 to 220 days. I've personally seen multiple incidents where the mechanism of discovery came down to customers chancing over their own stolen data on Pastebin. Traditional DLP solutions have struggled to stem the tide of data loss. Why? The simple answer is that the processing of data at the database is invisible to these tools. Traditional DLP solutions, powerful and necessary as they are, have historically focused on endpoints, attempting to detect sensitive data as it leaves an organization. For structured data, this is a great pity. It is much easier to detect database breaches at their source, in their pure form, before they are broadly disseminated and diffuse. Critically, corrective actions are much more likely to be effective before firewalls, which are just the last line of defense. Next slide, please. While Willie Sutton didn't actually say, because that's where the money is, when asked why he robbed banks, we're happy to say that's where the data is when it comes to our passion for protecting personal data in your databases. The data most critical to the GDPR and which is likely to get the brunt of enforcement activity is structured data, And the place to measure, understand, and protect it is the database. It's just that simple. Next slide, please. Here's another way of looking at it. It's reasonable to ask, why not reuse an investment you've already made? Why not fall back on familiar tools? Will your data activity monitor suffice? Unfortunately, no. DAMs are fundamentally not about discovery or even security, but are aimed at a forensic use case associated with SOX compliance. They rely on such invasive agents or manual configuration that they are typically deployed to a very small set of databases known to contain narrowly defined SOX data. By their very nature, they cannot discover where GDPR implicated personal data resides across your environment. While tools that address unstructured data are necessary, they are utterly incomplete in regard to the GDPR. If you process any significant volume of personal data, the most critical and largest segment will be in structured form. No big surprise. We leverage valuable or sensitive information with databases. It's what we do. It's all well and good to track when and how this data is converted to unstructured form, but this tells us little about where personal data resides in an enterprise. Consulting and other people-intensive services can help, particularly to establish wise policies and frameworks. However, the heavy lifting on an indefinitely recurring basis with regard to structured data makes these services unsuitable for continuous compliance. Remaining GDPR compliant is a significant challenge. Many aspects of that challenge can be aided by your existing tools and vendors. To the extent you've invested in solutions that can help, by all means leverage them. Just be leery until you fill the gaps surrounding continuous GDPR compliance of structured data. You are now at significant risk. Next slide, please. It's not easy to manage a structured data environment, particularly one now impacted by GDPR regulations. They tend to be complex, often growing organically and encompassing multiple technologies, connecting hundreds or thousands of database clients and services. Adding to this complexity is evolving application software, often processing increasing amounts of personal data at high volume. This is in stark contrast to static documents. Structured data evolves quickly over time, clients and services change, applications are upgraded, and the data itself accumulates in great volume, metastasizing from a purely regulatory point of view. This complexity can make it very hard to manually answer simple, innocent questions like, where is the personal data I process? Or, what kinds of personal data do I have? Or most critically, what is the legitimate purpose for this data? But these are exactly the questions we must be prepared to answer to prove GDPR compliance. Indeed, Articles 30, 32, 33, 35, and several others applying to the rights of the data subject hinge on your ability to answer them. The setting for this will definitely not be academic, and the pressure may be great. In each case, the key to success is to separate the complexity of your structured data environment from these otherwise simple questions. Next slide, please. What makes this possible is the same reason DB CyberTech is so different from other GDPR compliance solutions. Consider this Venn diagram. A portion of your information technology investment handles databases hosting structured data. All too typically, a substantial portion of this is like dark matter, perhaps accrued through acquisition or other processes that leave you blind to its existence. We call this the shadow IT. Personal data, data subject to the GDPR, comprises some portion of your known and shadowed databases. To separate the questions, where is the personal data I process, from what are my structured data processing activities, You need a complete and accurate picture of your entire structured data processing environment. Then, with your GDPR-regulated target in sight, you can effectively make it smaller, monitored, controlled, and minimized. Sounds good, but how? First, DB CyberTech is easily and almost trivially deployed to give you real-time, non-intrusive visibility into all of your data, both the visible and the shadowed. This is complementary to the agent-based approach DAMs and traditional DLP suites rely on. It means we incur no additional overhead to overload your databases or perhaps tickle the Oracle licensing dragon, and yet we listen to virtually all of the client-server conversations. Building on this visibility, we automatically discover and map this data. We build up an accurate inventory of structured data and associated processes entirely on our own, without bias or assumptions. I cannot overstate how surprising the results invariably are. Suffice it to say, structured data environments evolve organically. Data is the lifeblood of this organism. It goes everywhere, and we must look everywhere. Based on hundreds of examples I've seen in the field, you probably have 50 to 100% more databases than you think, perhaps many more. There are very real revenue and risk implications to this statement. To understand the interactions inherent in the rich inventory we discover, we apply our own custom behavioral modeling. If every one of your employees and digital servants did the same thing every day of their employment, you wouldn't need sophisticated modeling. But we're dealing with a diverse mix of human and machine behavior. We must model each database and application infrastructure algorithmically to understand and contrast what is normal from what may be an attack. Static, offline models or handcrafted learning cannot possibly keep pace with this perpetually changing environment. Indeed, most tools don't even have visibility into it. To achieve our behavioral modeling, we go far beyond the surface of database conversations. We must understand their nuances in complete detail, much the way you might listen to two people speaking in a foreign language and know who is talking, or perhaps how passionately. If you don't understand the language, you simply won't get the message. We understand multiple database dialects and process hundreds or thousands of concurrent conversations in real time and glean the tables and other database objects that are accessed, how they are used, all within the complete context which links database clients with their services. Here's some real magic. We can tell what kind of data is being exchanged too. We'll delve into this in just a moment, but this has an enormous payoff for GDPR compliance. Over tens or hundreds of thousands of distinct conversations, we pluck out exactly where personal data resides, what kinds of regulated data these may be, and how they're processed. This mercifully divorces the scale and complexity of your structured data processing from your compliance requirements. We find just the right needles in just a few haystacks. Next slide, please. How do we do that? First, let me explain what feeds our data classifiers. When we listen to database sessions on the wire, we can immediately tell from basic TCP/IP protocols what client and service IPs and port numbers are involved. However, we must decode the Layer 7 application protocol to truly understand the nature of the conversations and the data involved. There is nothing at all standard about the various client-server protocols of commercial database technology, but we support the vast majority of relational databases. With this information in hand, we can build up a data map describing clients, including their login names, database listeners, services, and the various database dialects they're talking. If we stopped right there, we would already have a wealth of interesting information to explore, but we wouldn't necessarily understand what personal data might be involved. For that, we need data classification. Our approach to this focuses on metadata and boils down to a sophisticated, flexible exercise in translation. The input to this process is much richer than you might expect and consists of the data access language used by database clients to query and modify the databases they access. Far and away, the most common data access language is structured query language, or SQL, universally used to access relational databases and many others. Fully decoding the language of the conversation yields a huge amount of important metadata, including all of the formal aspects of the query language, including various identifiers and labels describing the tables, columns, or other database objects accessed. We also consider query-specific things like column aliases, by which human programmers often describe the specific purpose of the data they access. On top of this, we consider the informal human comments often littering queries, quite often best betraying the meaning of the data. We use an assorted mix of custom natural language processing to map these SQL semantics, the metadata we see, back to natural language and the human meaning of terms we infer. We then search for the semantic terms within a representation of regulations, in the current case, the personal identifying information specified by the GDPR. Did I mention flexibility? The GDPR goes out of its way not to nail down an exact definition of personal data. While its purpose is clear, its exact meaning depends upon context. What is personal data in your environment might not be personal data in mine. Our data classification technology recognizes and handles this variability. Our data classifiers specifically for GDPR are an excellent starting point and are continually being improved. But we also allow for nuanced extension and even wholesale changes to this specification. We also make it very simple to allow our users to specify specialized encodings and what they consider to be personal data in natural language. Next slide, please. The result looks something like this. From the vast sea of SQL statements, often consisting of millions of artifacts spread across thousands of databases and applications, we pull out simple facts, for example, that a street and a mailing address are being processed, and in an all-important context, of course. Such personal addresses are mapped to a specific category of personal data within the GDPR. Within the blizzard of database activity, you can effectively evaluate each client service interaction to answer the question, where is my personal data? This can happen over and over again, perhaps thousands of times a second, spread over many different database conversations. But we find various needles within just the right haystacks. Some examples: the specific databases hosting the data, quite specific tables and columns within, the equally specific clients, humans and applications that access them, the kind of data involved and its direct relationship to the GDPR, and the strength of this evidence. This is what we mean by continuous. We leverage the very technology that makes structured data environments complex in order to make them manageable and ultimately compliant to the GDPR. Now it's time to demonstrate the real thing. I'll show you the DB CyberTech's GDPR compliance solution after it has been exposed to a typical structured data environment. We'll step into a day in the life of an analyst, perhaps a DPO. Along the way, you'll see what kinds of personal data exist, how they are accessed, and how that has evolved over time. I'll show you an example of data classification and some of the reports it can generate. Here's the dashboard of our GDPR compliance product. We've entered a system with a few days of automatically accumulated data. I'll explain a bit of what you're looking at and then drive through a reasonably detailed analysis with a simple investigation thrown in for good measure. Across the top, we can see an overall summary describing the level of GDPR-regulated data across the enterprise. This data is broken down by database service, client service connections, and SQL statements. On the upper left, we can see there are 119 database services processing GDPR-regulated data out of almost 6,000. This small 2% share is pretty typical in medium to large enterprises. This percentage and the absolute number are good things to keep an eye on as you track changes and the long-term success of your data minimization efforts. With this insight, if you had to respond to a data subject's request, you would need to consider only 119 databases instead of 6,000. Next to this, we see there are 243 connections to those GDPR-implicated services. By connection, we mean a distinct group of database activity with common client, login user, and database service. By isolating GDPR-regulated services, this is a quick measure of how broadly this sensitive content is accessed by client hosts and login users. Over time, these connections are remarkably stable. Any significant increase means your GDPR data is being more broadly disseminated. If you have not already anticipated that change with the data processing impact assessment, it's a good bet there's a gap in your process. On the far right, you can see a visualization of the different kinds of GDPR data that are being processed in this environment. The size of the bubbles indicate the raw number of matches found for a particular term. We highlight special category data in purple, since they carry additional restrictions under the GDPR. We also allow you to customize what is considered GDPR data in your organization. We start with a good, reasonably comprehensive definition, but you can use local context to improve the accuracy of the result. Any locally customized terms found are highlighted in orange. The details behind our findings are listed below the summary as a drillable table. This top-level list goes a long way towards satisfying the GDPR Article 30's requirement for a record of processing activities. You can easily export this view to a CSV or PDF file to share. Let's suppose you get a question from your security staff about whether and where you process debit card data. With the search feature of this table, you can discover the truth instantly. It looks like there is just one service, Invoices, which is such data. It is a Microsoft SQL Server service running on IP 10.1.40.32. We can drill down into it to see what's up. Now we see a new level of detail specific to the Invoices service. Just as before, this data can easily be exported if we'd like to share. I'll also point out while we're here, you could exclude this service from the default results if, for example, you have knowledge that this is just a test database with dummy data. Let's see how the personal data of this service is being processed. Most of the action appears to be from the SA user coming from 192.168.1.14. But what's interesting is that the sysadmin user, which we happen to know from experience is a DBA account, is accessing credit and debit card data from 10.4.80.2. That's a little suspicious. Let's dig in. This is a preview of the actual queries the sysadmin has used. We can drill down to see the full text. Wow! It looks like the DBA dumped all of the credit card and debit card numbers from the order details table. If you'd like to share that possible trouble immediately with your security staff, the details about where and how it happened are at your fingertips. So you can see, with just a few simple actions, it's easy to track, share, and explore GDPR-regulated personal data and processing activities across hundreds or even thousands of otherwise opaque structured databases. This concludes our short demonstration. As you've just seen, the powerful capabilities of our GDPR product make continuous compliance for structured data not only possible, but simple and intuitive. Our non-intrusive data mapping and intelligent GDPR data classification automate the work required by Article 30 to assemble your record of processing activities. By continuously monitoring those activities and proactively modeling normal activity, you significantly address Article 32 security requirements, while drastically reducing the investigations necessary to satisfy Article 33 breach notifications, as we've just demonstrated. With granular visibility from the high-level dashboard down to individual SQL statements, you can easily assess the risk of a change in processing activities for a data protection impact assessment as mandated by Article 35. Finally, you can take the uncertainty out of satisfying subject access rights. You'll know where you have various types of personal data, so you'll know just where to look for the data on specific subjects. Over time, you can measure how successfully you have minimized that sensitive data footprint. None of this is possible or even feasible without this unique solution. Next slide, please. To sum up, with DB CyberTech's GDPR compliance solution, you get the best-in-class GDPR product for structured data, automatically and continuously maintaining an inventory of personal data processing and providing immediate insight into where these occur and how they are impacted by the new regulation. No other technology can even listen to the enterprise-class database conversations at scale, let alone accurately and autonomously identify GDPR-regulated personal data. I'd like to thank you for taking your valuable time today to better understand the challenges and opportunities before us in remaining compliant with the GDPR for structured data. Please contact us at dbcybertech.com to continue the conversation and set up a demonstration. Now, let's open the floor for questions.
Thank you. If you have a question, please press *1 on your telephone keypad. If you are using a speakerphone, please make sure your mute function is turned off. A voice prompt on your phone will indicate when your line has opened. You may also enter questions at any time throughout the webinar by using the chat feature located in the lower left corner of your screen. And we will pause for a moment.
Hello, this is Dave Rosenberg again. So I'll take the first question, which is, how do you get all that traffic? The answer is actually pretty simple, but it's subtle. So we're dependent upon capturing a copy of your network traffic. And the two simple answers are that could be a network tap, which is very common with our enterprise customers, or it could be something as simple as a switch with a mirrored port. But the key idea is we're not inline. It's a passive technology. It's a common technology as well. And it can't possibly affect the connectivity or the performance of the databases or the applications. Second question I've heard was, do you require database credentials to identify personal data on databases? And the answer to that's also straightforward. No, we don't have credentials. We don't require credentials. We're reading that traffic and decoding it. So in fact, there's no need to even identify the databases affected. It's only important that they be captured, that their traffic be captured in the feed that we see. The third question we got is, how do you identify a user? So the answer to that is, the users we'll see when we look at database activity are login users. So for example, if it's a SQL database of some kind, there'll be an initial login user. It could be an application user. Could be a DBA, could be a personal account, just depends upon how it's accessed. That's the user we'll actually see directly. So a fourth question we see is, what sort of data classifier do we use, and what kind of technology is it, where we get it from, that sort of thing? The answer is actually it's a bespoke technology we developed directly based on our needs, right? So what this is about is a kind of natural language processing. And without beating it to death, it starts from the identifiers that we see in SQL statements, including the kinds of things you'd expect to be part of the SQL statement plus comments. We bubble that up, so that we finally understand what real terms are we referring to. And that's the kind of semantic analysis. And then we take that and compare that to a representation of the data classifier itself, in this case GDPR, and that's how the results come back out. So it's our own technology. Another one I just heard was, let me see if I can read this properly. There we go, get my glasses on. Question from Terry. If a new database with personal data is added, will you see it immediately? The answer is yes. So we're continually monitoring. In fact, that's the whole focus here, is that it really isn't sufficient to go out and one time only discover those databases you have, because in fact new ones come along all the time. So we're looking at that traffic continually, we're looking for changes, and we'll detect a new database source if that's what happens. So another one from Ben. What are you looking for? Hang on a second. I got to read it right. What are you looking, name, address, to identify GDPR personal data? So basically we have an entire, it's not a dictionary, it's got more structure than that, but it basically understands how the GDPR breaks down personal information and what kinds of names are being identified. So in fact, we know various identifiers for people's personal names, for their biographical or biometric sort of quantities. Those are actually special quantities, that sort of stuff. And that entire representation is something that is extensible in the product. So we've done a careful job and tried to map out those things that might make sense, but they're definitely extensible. And in fact, that's the next question. Can I supply my own terms? Yes, you absolutely can. It involves things like terms. It also involves things like in people's own SQL applications. Sometimes things are compressed and encoded in interesting ways, really abbreviations, if you will. There's a way to also describe that. I think that's all the questions we have right now. So I want to thank everybody's participation in this, and we've all enjoyed it. Thank you.
And that will conclude today's call. We thank you for your participation.
That was